Okay, today we're going to be graphing quadratics and square roots. We've already done it before. We went over parent functions like the very beginning of the year. So a lot of this should be review, but I still want to go through it and make sure we're all on the same page. So the notes will take a little bit longer just because I want to make sure we're all together. But it really should be review. We've gone over all of this before. So let's start out with quadratics. Your quadratic parent function is y equals x squared. Okay, so let's kind of go through that first because that's what all quadratics are based off of. So any parabola you see is either moved up, down, left, right, shifted, or stretched, or whatever based off this parent function. Okay, so first thing we're going to do is make a table. And you want some negative numbers and some positive numbers. That way you kind of know what's going on with your parabola, with your curve. Okay, so go ahead and fill out your table. Your x is -2, -1, 0, 1, 2. Okay, and if we plug those numbers in for x in our equation, what is -2 squared? Okay, -2 times -2 will give you a +4. So my y would be 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Okay, so you have your table. Now we're going to plot those points. Oh, whoops. Okay, so -2, 4, and yours will probably look much better than mine. -1, 1, 0, 0, 1, 1, 2, 4. Okay, so you have your parabola. This is what your parent function looks like for quadratics. Like I said, a lot of this should be review, just a refresher. Okay, domain and range. Domain is all of your x values. So look at your x-axis. It goes from the left side to the right side, right? So we want to look at all the x values from the left to the right. And for this graph, if I look at the furthest spot to the left, I have an arrow, right? That means it's going to keep going on forever and ever and ever. So it goes to the left forever and ever, and it also goes to the right forever and ever. So my domain would be from -infinity to +infinity. Okay, so you can either write it like this with the infinity signs, or I'm fine if you just put all real numbers, that all real numbers symbol. Either one, it's totally up to you. Okay, range is all your y values. So you want to look at your y-axis now. And your y-axis goes from the very bottom all the way up to the very top. So my lowest point for this graph, my parent function, would be 0. And then it's going to keep going up forever and ever. So my range goes from 0 to infinity. The 0 is going to have a bracket because there's actually a point there. Okay. Infinity has a parentheses because you can't touch infinity. So 0 to infinity. The other way you could write this is you could say that y is greater than or equal to 0. Either one, whatever makes more sense to you, whatever you can remember the best. Okay, but that's what we're working on today with quadratics. We're going to start moving these parabolas left and right, up and down, and finding the domain and range after we do that stuff. Okay, but this is what all of our quadratics are based off of. So let's try that next example, y equals -x squared. Okay, we're going to graph it, and we're going to say what kind of effect happened on this graph. So let's see, the next one is y equals negative x squared. Now I'm going to graph it. So let's use our calculator for this. Go to y equals, okay, put in negative x squared, and then I want you to go to your table. Okay, and find some good points that you can plot. So I'm going to give you about 10 seconds, 15 seconds to go to your table, find some good points, and plot those points. We need to do it kind of quick, or else these videos, these notes are just going to take forever. So let's get a move on it. Go to y equals, put in your equation, go to your table, and plot some good points. Okay, so you should have come up with 0, 0, -1, -1 was a good point, -2, -4. If you want to keep going, do -3, -9. But those will be some good points. 1, 1, or 1, -1, I'm sorry. 2, -4, 3, -9. So you get this upside down parabola. Okay. So on the bottom where it says what effect happened, the effect is that it flipped upside down. So flipped upside down. Now the technical way of saying this, the better way to say flipped upside down, would be to say that it reflected over the x-axis. So go ahead and write that down too. That way if you ever see it or here, oh, it was reflected over the x-axis, you know what it was talking about. Okay, reflects over the x-axis. Okay, and the reason it does that is because you have a negative in front of that x squared. So anytime you have a negative at the very beginning, it's going to flip upside down. Okay. Now I'm going to give you 15 more seconds. You're going to do the next example. Okay, go to y equals, put in parentheses, x plus 2. Close your parentheses and make sure that squared is outside the parentheses. Okay, and then go to your table, find some good points to plot, and make your graph. So 15 seconds. Okay, so some good points you should have found would be, let's see, -2, 0, -3, 1, -4, 4, -1, 1, 0, 4. You might have found the point 1, 9, and -5, 9. Okay, so the effect that happened to this graph, can y'all tell what happened from the parent function? How this parabola moved? Okay, look at the top of your notes, your parent function, and look at this graph. How did they change? Okay, and this parabola moved to the left too. Everything else is the same. It didn't move up or down, it just moved to the left too. So if it's inside the parentheses, see how that +2 is inside the parentheses? If that happens, it's going to move it left or right. And remember, it does the opposite of what you think. So if I have a +2, it's going to move it to the left too. So go ahead and circle that. Okay, so last example on this page, we have y equals parentheses x minus 2 with the squared outside. Okay. Let's just go ahead and do this one without the calculator. Okay. So if this plus 2 inside the parentheses made it move to the left 2, what's the minus 2 going to make it do inside the parentheses? Okay. It's going to move it to the right 2. So let's not worry about the calculator on this one. Let's just take our parabola that's normally at the origin, that vertex, and move it to the right 2 this time. So it's going to look something like that. Okay? So if it's inside the parentheses, it's going to move it left or right. Alright, turn to the back. Let's see. Our next graph, we have plus 2 outside the parentheses. So, if you remember from the beginning of the year, what is the plus 2 outside the parentheses going to make it do? Plus 2. Okay, if it's outside, it's going to move it up or down. So, and it does exactly what you think. So if I have y equals x squared plus 2, my parabola is going to move up 2. So the effect would be that it moves up 2. So I'm going to take my vertex, which is normally at the origin, and I'm just going to move it up 2. So 1, 2. So remember, if you have a number outside the parentheses, it's going to move it up or down. Okay? And this works for all functions. Even square root, like we're about to talk about. If it's outside, like the next example, it has minus 2 outside. That minus 2 is going to move it down 2. So let's make our graph. Instead of the vertex being at the origin, like the parent function does, we're going to move it down 2. Everything else will stay the same. Okay, so the effect is that it moves down 2. Alright, so any type of variation in my equation from the parent function, so like my parent function is y equals x squared. Anything that's different from that is going to change that graph in some way. So you need to tell me what each one makes it do. And we'll start looking at ones that move it left and down. Instead of just one effect. You'll have more than one. Okay, let's look at the last two. The last two examples have a number written in front of the x squared. Anytime you have a number in front of x squared or in front of your parent function, it's going to stretch it. So this 2 is actually going to stretch it by a factor of 2. So the effect is that it's stretched by a factor of 2. Okay, so I'm going to give you 15 seconds. You're going to put this in your calculator in y equals. Go to your table, find some good points, and plot those points on your graph. Okay, so let's make it quick. 15 seconds to look at your table and plot some good points.